Okay, let's look at how to describe local and end behavior for functions. So if we look at this one here, we've got our denominator x minus 6. So if we set that equal to 0, we get x is equal to 6. And that's going to be a vertical asymptote. And it's also going to give us the domain is going to be all real numbers except x equals 6. Now we can get our numerator. If we set that equal to 0, we can get our x-intercept. So the x-intercept is basically going to be 0, 0, because if we say y is 0, then the only way this can be equal to 0 is if that's 0 as well. And then our y-intercept is if we set that equal to 0, and we get 0 again. So our y-intercept and our x-intercept basically are going to be the same thing. All right, so moving on to the next things, we see that this is an asymptote and it's got an odd degree or multiplicity. And so when x is equal to 6, somewhere out here, that's going to be, it's going to have the feature that it's either going to have it coming down like this and then up like this, or it's going to be coming up like this and down like this. And so we really need to figure out how the other items are. Now, if we notice that we have equal degrees, and so because of that, the horizontal asymptote is equal to y equals 2, because it's just going to be the 2 over 1, which is 2. And so then we have the horizontal somewhere in that vicinity there. We have our 0, 0 point there, and it's going to probably erase as soon as I get it done. Yep. And so I don't know how you're supposed to draw a circle without it erasing. All right. Now, because we have this multiplicity of 1, what's going to happen is we're going to keep below the graph here, and we're going to come down, and we're going to do something like that. And so when it comes down here, this one has to come down like this, and we'll have something like this. It's going to be a shape of 1 over x roughly. And so this is going to be the rough shape of the graph. So the local end behavior here is, and again, this is still our asymptote. So as the x approaches 6 from the right, then that's coming from this direction, the f of x is going to approach positive infinity. Now, down here, as x approaches 6 from the left, the f of x is going to approach negative infinity. And then at both the end directions here, as the x approaches plus or minus infinity, basically our f of x is going to approach, and that's going to be the y equals 2, and so it's going to approach 2. So it was going to come from this direction, and it's going to come down from this direction. So those are the local and end behaviors of how the items are going to be looking. Now let's look at one more. So on this one, we don't have it in factored form, so we get to factor it. And if we think about this, this is going to be x minus 3, x minus 1, and that's because negative 3 times negative 1 is plus 3, and then minus 3 minus 1 is minus 4. And on the denominator, it looks like we're going to have x minus 5, x plus 1. And so in this case, both of these are going to be multiplicity of 1 again. And so that means we'll have, something like, this and this, or the other way where it's coming down and coming up. So it's going to do something like that depending on how the points and stuff are. Setting the denominator equal to 0, we have vertical asymptotes at x equals 5 and x equals negative 1, and nothing cancels, so they're going to stay there. And so our domain is going to be all real numbers except at x equals 5 and x equals a -1. Okay, we have the y-intercept, so x equals 0, and then y equals, well, if we plug in 0, all those go away, and we get -3/5. And so we get 0, -3/5 is going to be our y-intercept. Our x-intercepts, those are going to be, when we set those equal to 0, we're going to solve for x. And so we're going to have a 3, 0, and then if we add that one, it's going to be a 1, 0. All right, horizontal asymptote. All right, so we have the same power, so we use their coefficients, which is 1. So we get y equals 1 is going to be our horizontal asymptote. And so let's think about drawing this. So what do we have? We have the horizontal at y equals 1. We've got vertical at 5, so somewhere way out here. And at -1, something like that. Where do we have our intercepts? Well, we have one at 0, -3/5, so somewhere roughly there. And then we've got the x's at 3, 0 and 1, 0. So 1, 0 is going to be probably there. And the 3, 0 is going to be closer out this direction. And so what we need to do is we need to draw what's in the middle here first, because that's going to really affect how the other pieces are. Since this is going to have 3 pieces, you're going to have one over here, one in the middle, one over here. And so this has to go up, go through that 3/5 part, go over here, come back down, and do that. And that's just because we have to hit all those points, and that's the way it's going to happen. Now, since this one's going down, this one has to come down, go this way, and the same thing here. Okay. All right, so looking at this one here, we can say as x approaches a -1 from the left, the f of x approaches positive infinity. And then as x approaches -1 from the right, going this direction, it looks like f of x is going to -infinity. Then when we have the 5 here, so as x approaches 5 from, say, the left, then f of x is going to approach -infinity. And as x approaches 5 from the right, so from this direction, f of x approaches positive infinity. And then we can say, for going out each direction, as x approaches plus or minus infinity, because either direction we're going, then what we can say is f of x approaches 1. So it's going to approach 1 as it keeps going further out that way, and the same with that way. And this one, you know, x in the middle here, it approaches 1, but it doesn't get there as well. So that should be our end behaviors for that one as well.